Good morning, mathematicians. Back to chatting. Will we make glacial pace, glacial progress through a paper in algebraic number theory? That's just what we do around here, apparently. You know, the last couple days, I've said I should not have long office hours, and I meant it, and I still shouldn't. But I did kind of, yesterday was like 50 minutes. I can't be doing that today. Same black background as usual. You were clickbaited. Progress is progress, yeah. Progress is progress. Okay. Where were we here? Somewhere around here. Something about the reciprocity map. Preserving... assume... Yeah, something about... Wait, 3i. So if there's a... Oh, why is OBS like this? Are we gonna have... Oh, why is OBS like this? Are we gonna have this disconnection problem again today? Yeah, I don't know. Why is it doing the stupid disconnecting bullshit again? Actually, I don't think this fixed it last time, but... go turn my Nord off. Might help. Okay, we'll see. I'm doubtful that it will help. I wonder if I take my phone off the internet too or something. Hey Femno, how's it going? Okay. The local reciprocity map is injective. The local reciprocity map. Right. Wait a second. What's the local reciprocity map? Local reciprocity map. You saw the computation of pi k+1 sk for the first time today and can finally appreciate my profile pic. Nice. Hell yeah. Hell yeah. Right. Wait a second. Wait a second. This map goes into the global group. Gotta remember our global our class field theory videos. By assembling the maps called local art and symbol, the local reciprocity map is here. Okay, but this should have an idyllic formulation. Do we have to go back to Milne? Do we have to go back to Milne? To Milne, or where's my CFT? Maybe Kepaya. You wanted to learn the spectral sequence proof because you've never learned spectral sequences, but you were advised against it. Didn't we do a spectral sequence? Didn't we do a hop vibration spectral sequence in my spectral sequence series? I don't remember. Hello, QB and Casta Kachori. I'm gonna go get a piece of chocolate. Gotta have a bit of dark, super dark chocolate every morning to live forever. Boris, you should have been hanging around during the Spectral Sequences live stream. I mean, they're all still there on YouTube, but we're really getting sidetracked here, though. Adelic reciprocity. Additive characters. Main results. Where's the adelic reciprocity map? Okay, whatever. That's probably what it means. I don't know. We're wasting time here. Am I doing actual research or answering questions from the audience? Yes. I'm doing both. Yeah, I mean, I'm currently I've got, papers open. Technically, this isn't my research area, but there is a part of me that kind of wants to say something about this one day. But I'm also reading this. I'm like, God, there's so much I have to get caught up on. But if you have questions, then feel free to ask away. I mean, I think yesterday's video, right? I was doing the same thing, looking at these same papers, but then I stopped to answer a question about like what's an injective function. Sorry, Alexander, what were you asking about? And yes, I've heard of jet bundles. My research is about the p-adic Kasdan-Lustig hypothesis. That's what it's been about so far. Okay. So local reciprocity map is injective. So it should suffice to read this off from the isomorphism type. Let this be a torsion subgroup of an abelian group. This is a p primary part of a finite abelian group, and assume that the norm is equal to this. Then the following facts follow from here. P is uniquely determined by this property and this. Interesting. What's reference 16? Oh, it's from Neukirch. Okie doke. Okie dokie. So indeed we have 4. Okay. You see great potential in them for Yang Mills. They're a good way to describe Lagrangians. Jet bundles are a good way to describe Lagrangians. That's interesting. You know diddly squat about physics. What's a book to actually get up to speed on modern stringy math? I feel like you got to hit some things in between there. Remember yesterday? Yes, I remember yesterday when you mentioned the Abel-Ruffini theorem. You read the original proof and studied a little Galois theory. Have to concede Galois proof is better. Aha. Aha. Yep. Indeed. Galois proof is better, and it will take you further, right? It'll take you further because those same ideas you can use to do a whole bunch of different stuff, right? You tried sitting in an electrodynamics class. Yeah, the problem is, here's the problem, I think, with physics. In order to really understand the quantum mechanics, for example, I think it's really, really helpful to have a proper course in classical mechanics. But classical mechanics seems so boring to me. So, yeah. Your conversion has begun. You regret not getting an undergrad in math. Well, at least in theory, you've picked up the skills of teaching yourself, and so you can still give yourself an undergrad education in math. The classes were all just strings of uninterrupted equations and calculations with 0 words. Yeah, I mean that'll make it unenjoyable. Currently doing your first big project for the end of your 3rd year in math. Any advice? Any general advice for your first big project? I don't know. It's a broad question. Work hard. Yeah, I don't know. If you haven't picked your topic yet, make sure you pick a topic that you really think is interesting. Of course, you may pick a topic, and then only realize later that you don't care about it as much, which is problematic. And then you got to push through anyways. Yeah, I don't know. Get feedback. If before you hand in the final draft, you can send in like a rough draft, to, I don't know if there's someone supervising it or a prof you could talk to and just say, hey, would you mind, if you have time, giving this a quick look over and just giving me a couple pointers? That's probably a good idea. Get some feedback on it. When does the transcendence degree stop increasing for field extensions? What do you mean by that? Can't you can always just add another variable, right? I mean, if you take a field, to be honest, I never learned transcendence degree stuff properly. But I think if you take any field, you can just formally adjoin some variable to it. And then now this is a transcendental extension, right? Just rational functions over that field. And that should have a bigger transcendence degree, so I don't think that ever stops. All you miss in math education is the abstract algebra. Well, you've come to the right place, I suppose. Well, maybe, Leo, you need to go back to bed. That's my advice. You self-studied with it and enjoyed it. You're Russian, so maybe your native language is simplifying things. Well, I'm glad if that was uh, that was helpful. You can only read math books under 300 pages. You rather have a 5-point font size than a 900-page monstrosity. I don't know. Is that true? Is that true for me? I don't think that's true for me. You only tried to read Stat Mech 1. I could maybe appreciate Stat Mech now more at this stage in my life. Yeah. Also, guys, don't talk about reading in front of Leo. He doesn't like it. String theory is what a physicist that knows mathematics well brewed together, and what mathematicians have become intrigued by, since it was simpler to understand than QFT. What? Isn't it built on top of QFT? What's the most abstract modules that I've encountered? I mean, the cheap answer here is just literally any time, literally any time I've written a proof, let M be an R module. Let R be a ring, and let M be an R module. Okay, that's a cheap answer. I've proved many results. You know, the first results you prove in module theory are results of this form. It's not wrong, right? You can't get more abstract than choosing an arbitrary R module. So now, what's one that has the most like convoluted definition? I don't know. Yeah, I don't know. Most complicated R module. I don't know. Modules are supposed to not be complicated, right? I mean, I guess they obviously they can be, but formula proved using TQFT. Interesting. You know, expert on string theory, but your gut feeling is it gave us more math. Yeah. So bonus. We went digging for gold and we found uranium. QFT is very non-rigorous, based on physical intuition rather than hard mathematics. You know, I feel like for most of my life that turned me off from it, and that made me think that like, yeah, that made me disgusted with it. But now that I'm getting older, I'm like, I don't know, maybe that's what's up actually. Worst module is probably whatever module you get out of Mitchell embedding. Yeah. Yeah, how far from. Yeah, 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 it's probably extremely non constructive. The nice thing about 26 dimensions is you make good use of your alphabet for coordinates. That's true. What are some special things that happen in 26 dimensions? I feel like there's some 26 dimensional Lie algebras of note. 26. Why 26? Yeah. Isn't math insight to reality, though? I don't believe so. My opinion is that math is just a fiction. It insists upon itself. Hi, Mom. Good morning. I love you. I hope you're feeling better. If you are, I'll call you. You've been just learning about rigorous constructions of QFT There's been quite a few advances in previous years. As far as you know, string theory has given very little insight into physical reality. Yeah, that is also my understanding. Mathematicians are disgusted by it. I was disgusted by it. But now I'm slowly coming to a place where I'm like, maybe rigor isn't everything. Okay, assume 3.12. Sorry, assume, yeah. Assume 3.2. What does 3.2 say? So what is the setup for 3.2? We have a norm-preserving isomorphism, which we just found out is actually any idyllic isomorphism. And we have, good morning, Russ. And we have an isomorphism of the abelianizations. And for all and phi is a bijection between the unramified primes of this and this. Interesting. Wait. Phi is a bijection between the unramified primes, and this seems like a lot of conditions. And phi of frob p is frob phi p in gal L ab psi n. Oh yeah, this should be psi n over L. This seems like a lot, though, right? I mean, that seems like it's asking a lot. But maybe not, right? Because it's, I mean, that should be the same as just them being isomorphic. So, I don't know. Wow, lots happening in chat. Advances, but still lackluster. Yeah, rigor isn't everything, but it is also everything. True. For a long time, you thought of math as an invention of the human mind. I'm still on that. Yeah, it describes some things in nature, but the math itself is an abstract tool. Yes, I've long time been of the opinion that it's useful fiction. And if a mathematician does want to study rigorous constructions, they have to know the non-rigorous perspective too. Yeah. Do we have the tools yet for somewhat elementary proof of FLT? I think there's people working on it. But no, we certainly do not have an elementary proof of FLT. And I think we're a long ways away from it. Although, who knows? One could imagine. I mean, I think we're still a far way away from this, but I think Kevin Buzzard is currently paying some people to help him formalize the proof of FLT in Lean. And so, I mean, that's a ways away. But one could imagine that actually that could be helpful. Having lots of things formalized in Lean could be helpful for reverse mathematics. where we go back and unpack dependency chart, dependency paths. So who knows? Like, yeah, maybe that could be helpful for that. But I think we're still a long way off. Tao's 3 stages, yes. Yeah, exactly. Took me a long time to approach any post-rigor. And I'm still not quite there. Something to be said for not being super rigorous in physics. Yeah. You're at a point where you don't know what you are. Maybe that's a good point to be. Maybe that's a good point to be. You learned nothing in that class that gave you any insights applicable to physics. Yeah, fair. Wait, nothing in that class that gave you any insights? Nothing? Yeah, then again, yeah, I did think about that too, about about Tao's 3 levels. And I did think about Tao's 3 levels and the fact that, like, well, that's true for him, but is that really true for all mathematicians? Because, I've seen a lot of stuff out there, and sometimes I'm not sure that most mathematicians even figured out the pre-rigorous. I shouldn't say most, but there's definitely some mathematicians that I don't even think quite made it into the rigorous phase, let alone, breaking through to the post-rigorous phase. You're fond of pointing out that PDEs, even Maxwell's, were a thing long before some quack came up with uncountable set. Yeah. Ended up majoring physics, but honestly felt more like a mathematician at heart. Isn't that why we're all here in chat today? I have a Wacom pad. I tried looking into programs, so I tried looking into reaching out so that I could sponsor them, but it seems like a hassle, so I don't know. You love rigor though, not only in math but elsewhere. Yeah, but I feel like Adib. This is a characterization of global fields by Dirichlet series. I don't know. I've become too rigid, too rigorous sometimes, I think. Not to say that all of my papers are perfectly rigorous. That's certainly not the case. But I feel that it's almost infected my thinking. As I've discussed with Leo, with this Wittgenstein, paralysis of whatever, getting trapped in these language games. At some point you can't be perfectly rigorous, right? You haven't heard of anyone working on an elementary proof of FLT? Isn't there people working on finding elementary proof of FLT? There's a question, why are people still looking? Yeah. Oh, a lot of false claims about an elementary proof. But yeah, I think there's people out there. I think there are people out there. Professionally, you do data science and stats. So sometimes you think your interests are too broad. Well, too broad for what? I mean, you're getting paid. You're making bank, and you still have time to hang out and talk math on the internet. So, will there be a part 2 with Kontorovich? I don't know. Maybe. I did feel like I had more questions, so maybe I'll reach out to him again and see if he has more time. ABC conjecture? That gives an elementary proof of FLT? Well, it depends what you mean by elementary, right? Because the ABC conjecture, like, is there a proof? I mean, okay, Mochizuki's proof is doesn't seem like it's panning out to be real, or totally, it's certainly not convincing. And even if it were, that's not elementary. So you don't have an elementary proof of FLT if it depends on a non-elementary thing, right? Automorphic lifting theorems are non-elementary. You recommend checking out Vinogradov's book on the geometry of nonlinear PDEs. Ooh, yeah, I've thought about that. I've thought about that before, about writing some math articles in a Socratic dialogue. It could also be fun for the channel, maybe, to teach something in a Socratic. I mean, Leo and I did that one live representation theory thing, but yeah, I don't know. Maybe something more scripted and streamlined. Or maybe non-scripted is good, but yeah, I don't know. Somehow more streamlined. I don't know. Terrence Howard. Don't make me choose, man. Don't make me choose. Don't make me choose between the two. At some point, you can't be perfectly rigorous. At some point, you have to leave the proof as an exercise to the reader. Yes, and you should. The more you leave to the reader, the better, am I right? Recently watched a project trying to make a theorem prover for making as short as possible proofs, and half the things you couldn't tell if it was just super confused. Looking forward to part 5 with Kontorovich. Yeah. How much time would you need to read and understand at least one paragraph of Mochizuki's first IUT paper? A year? A year? I think this is paper 1, right? So what do we consider the first paragraph? Summary of main results? No, I guess we should go to paragraph 1 of the actual argument, right? Where does the actual paper begin? The idea of exploring theories is cool, though. Yeah. Yeah, I mean, I did this little, I was part of this little project where we did some, like, network analysis on the structure of theorems proved in rock. So I2, is this the first real part? No, this is all still just introduction, right? Your math paralysis usually kicks in when you find there's some cool new thing or book. But if you invest the time, then there's a million things you couldn't read into, yeah. You swore to yourself to never say something as elementary when you were in undergrad. Not going to be a math snob. So I don't know, what counts as the first paragraph, though? I mean, this is all still introduction, right? It's all still introduction, technically. Here we go. Oh, this is notation and conventions. Yeah, elementary doesn't mean easy. Yeah. Okay, section 1. Here we go. Let L bigger than 5 be an integer prime to 6. Got it. X is a hyperbolic curve of type 1, 1. I don't know what type 1, 1 means, but I also don't know the exact definition of hyperbolic curve, but okay, I could believe it. Field of characteristic 0. Okay, no idea what an orbicurve is. What the hell? L torus? No idea. Who's k-core? Don't know what that is. Also forms a k-core of X. Thus, this determines up to k isomorphism, a hyperbolic curve, X bar defined to be this fiber product. I mean, nothing too crazy. There's a couple of words I don't know, but this doesn't seem too crazy yet. Moreover, if we write GK for the absolute Galois group, this for the arithmetic fundamental group of a geometrically connected, geometrically normal, generically scheme-like K algebraic stack of finite type, and this for the geometric fundamental group, the kernel of the natural, then we obtain natural Cartesian diagrams of finite étale coverings of hyperbolic orbicurves and open immersions of profinite groups. So that's a lot of nonsense I don't fully understand, but what? I mean, what is it? We have some curves, basic takeaway, we have some curves, those induce maps on fundamental groups, basically, right? So, not too bad. This whole stream is K-core. Amen. Yeah. Yeah, you called it, Boris. You called it. You own a tiny tome titled Elementary Number Theory and see undergrad level math book that you own. You understand the least. Well, time to crack it open. Time to crack it open. So there's an arithmetic fundamental group. Yeah. I mean, isn't that... I don't know exactly what that means here. Isn't that just... Yeah. Is this not just, like, the étale fundamental group? Is it not just a Galois group? Arithmetic fundamental group. Of a scheme. Yeah. Yeah, it says in parentheses the étale fundamental group. You bet Oppenheimer read the IUT paper? That's why you agreed to... Oh my god. That's brutal. That's brutal. Okay, that's gonna do it for today, though. Like I said, it's already been longer than I intended to stream. Man's got a thesis to write. So, QED! QED! QED!